Okay, so the last thing I want to hit you with today is the way in which what we just talked about, the firm's output decision, is going to differ in the long run compared to the short run. Now, the simple answer to this is that operationally, there really isn't much of a difference at all. In other words, the way that a firm is going to make decisions about how much to produce and whether to produce is exactly the same in the long run as in the short run. We're still going to say that if we produce, we're going to want to produce for our long run marginal cost, right, equals P. And we'll produce as long as, right, our price is greater than or equal to our average cost per unit, right, our average total cost. The only difference is that this, right, our average cost, C of Q, Q over Q, is going to equal both our average total cost and our average variable cost. And the reason for this is, in the long run, we don't have any fixed inputs, right? We can adjust our capital and we can adjust our labor. So as a result, our cost of producing 0 units is just 0, right? If we don't want to produce anything, we can get out of the market entirely, have no cost, no revenue, and profits of 0. As a result, right, we're going to say that our profit is going to equal our producer surplus, right, for the exact same reason that our average total cost equals our average variable cost, right? What's the benefit of a firm in the long run of being able to be in the market? It's going to be equal to the profits that they make in that market, because the alternative is earning 0, right, a profit of 0. So still, right, same basic decision. We decide how much to produce by setting marginal cost equal to price, decide whether to produce by seeing whether we do better by producing some than by producing nothing at all, right, producing our optimal or producing 0. The only difference is that we don't have any fixed costs anymore. Okay, so great. So this is the simple part of the story. The more complicated part of the story, and this is quite challenging, so I just want to warn you for a minute here, is the question of how functionally, how structurally decisions differ in the long run versus the short run. So we need to understand, right, the process for making the decisions is the same, but the decisions themselves are going to be different because our marginal costs and average total costs are different in the long run and the short run. So to see this and understand this, let's go back to our specific example, where we have some production function like f of Lk equals L to the 1/2 times K to the 1/4. I think we said let's have a wage rate of 20. And for mathematical convenience, I'm going to increase the rental rate of capital to be R equals 10. We said in the short run, right, we had capital fixed at 16. So as a result, right, we said that Q would equal L to the 1/2 times 16 to the 1/4, or 2. Right, L is going to equal Q squared over 4. And our cost function, our short run cost function, will just be the cost of Q squared over 4 units of L and 16 units of K, which is just going to be 5Q squared plus 16 times 10, so plus 160. Right, our short run marginal cost is just going to be the derivative of this with respect to Q, so it'll just be 10Q. And our short run average total cost will be just this divided by Q, right? So 5Q plus 160 over Q. Great. So this is the short run. The long run is going to take a little more doing, right, to get to find our cost function, because in the long run, we no longer are stuck with 16 units of capital. We can have as much or as little capital as we want, and we're going to choose capital and labor to minimize the cost of production, right, of producing Q units of output. So how are we going to find this? How are we going to find our cost function? What we're going to do is we're going to find the quantities of capital and labor that minimize our costs, and then see how much they cost us. So we'll start with our MRTS. MRTS of LK, which is going to be dF dL over dF dk, right? dF dL is going to equal the derivative of this with respect to L, so it'll be 1/2 L to the negative 1/2 k to the 1/4 dF dk, be the derivative with respect to k, 1/4 L to the 1/2 k to the minus 3/4, right? So our MRTS is just going to be dF dL over dF dk, 1/2 L to the minus 1/2 k to the 1/4 divided by 1/4 L to the 1/2 k to the minus 3/4. Right? So we can calculate this just one piece at a time. 1/2 divided by 1/4 is 2. L to the minus 1/2 divided by L to the 1/2 is 1 over L. And k to the 1/4 divided by k to the minus 3/4 is k. So we'll end up, out of this chaos, getting a nice clean MRTS of 2k over L. We know that we're going to have an interior solution, right? Because if we had no capital, we would have an MRTS of 0. No labor, we'd have an MRTS of infinity. Right? So we know that we're going to have MRTS equal to the cost ratio, 2k over L has to equal 20 over 10, which is going to give us the nice result that k equals L. From here, what do? We plug this into our isoquant, right? So we'll say Q equals L to the 1/2 k to the 1/4. So that means that once we plug in k equals L, we'll say Q equals L to the 1/2 times L to the 1/4. Q equals L to the 3/4. So L will equal Q to the 4/3. And since L equals K, K will also equal Q to the 4/3. Why does this help us? Because we know that our long run cost is just the cost of the cheapest labor and capital we can use in order to produce Q units of output. So we can say LRC of Q just equals WL of Q plus RK of Q. Plugging in our functions for L of Q and K of Q, we're going to get that our long run cost is equal to 20 Q to the 4/3 plus 10 Q to the 4/3. So our long run cost is just going to be 30 Q to the 4/3. Great. So then our marginal cost will just be this divided, the derivative of long run cost with respect to Q, which will just be 4/3 times 30 Q to the 4/3 minus 1, so Q to the 1/3. So this will be 40 Q to the 1/3. And our long run average total cost is going to be just our long run cost divided by Q, right? So that'll just be 30 Q to the 1/3. Okay, so this is a huge flurry of algebra, right? We've now covered the board in algebra. So let's stop and think about what we just did. So we've got short run cost functions that look very different from our long run cost functions. Right, in the short run, our total costs are going to be 5q squared plus 160. In the long run, they're going to be 30q to the 4/3. Those are really, really different functions. Right, likewise, our marginal costs, 10q versus 40q to the 1/3. So what's the relationship between these functions? How are our choices going to be different if we try to set 10q equal to p versus if we set 40q to the 1/3 equal to p? How are our total costs or our profits going to be different in the short run and the long run? In order to think about this, I want to back out from the math a little bit and just remind ourselves what the difference in the problem is that led to these different cost functions. Hopefully that'll help us make sense of how these cost functions are related to each other. So if we compare these two sets of cost functions, right, our short run costs and our long run costs, Our first impulse might be to panic, because they don't really look that similar to each other, right? But if we want to understand the relationship between these two sets of cost functions, let's remind ourselves what the difference is in the problem that led to these cost functions being different. So in both of these cost functions, we've got a wage rate of $20, a rental rate of $10, and a production function of L to the 1/2 times K to the 1/4. Right, identical wages, identical rental rates, identical production. The only difference between these two functions, the only difference between the problems that led to these functions, are that in the short run, we have capital fixed at 16, where we have 16 units of capital. In the long run, we have capital equal to Q to the 4/3, which is to say we chose our capital to produce our output at the minimum possible cost, right? So here we chose our optimal level of capital. Here, we're stuck with the same level of capital if we want to produce 1 unit of output or 1,000 units of output. So intuitively, we should expect that our costs here, our total costs here, should be bigger than our total costs there, right? It shouldn't be possible that forcing us to use 16 tractors, regardless of how much we make, would lead us to produce output at a lower cost than if we can choose the number of tractors that are cost minimizing. Right? That can't possibly be the case, because if 16 produced cheaper than Q to the 4/3, this wouldn't be our cost minimizing choice. The only exception to that, the only case where our short run costs shouldn't be higher than our long run costs, are if we happen to want exactly 16 tractors, right? So in other words, if 16 equals Q to the 4/3, if Q equals 16 to the 3/4, which is 8, then we would have the same costs, right? So we should expect that our short run costs are going to be greater than our long run costs, unless Q equals 16, or Q equals 8, right? K of Q happens to equal 16, in which case our short run costs would equal our long run costs. Right? So except for the case where the amount of capital we'd like to use is exactly the same as the amount of capital we're stuck with, our short run costs should be greater than our long run costs. So let's test this. Let's see if this is true. So if Q equals 8, right, we'll have a short run cost of 8 equal to 5 times 8 squared plus 160, right? So this is what? 8 squared is, oh my gosh, 8 squared times 5 is 320, right? And then, because 8 squared is 64, plus 160 is 480. Long run costs, producing 8 units of output, are going to be 30 times 8 to the 4/3. This is going to be 30 times 16, is also equal to 480. Right? Because 3 times 16 is 48. So exactly as we expected, right, our long run costs and our short run costs are exactly equal when we're producing a level of output where 16 tractors is optimal. If we graph this thing, what we'd see is essentially our short run costs, right, start out at 160. They start out really high. Then we know that they're going to equal 480 when we have an output of 8. Right? They're going to look something like this. Our long run costs, we know start below our short run costs. Right? The cost of producing 0 in the long run is 0. They're also going to equal exactly 480 at a price of 8. We know that they're lower than our short-run costs at low levels of output, right? Because we're not paying a fixed cost of 160. We know they've got to be lower than our short-run costs at high levels of output, right? Because if we keep increasing Q, Q squared grows faster than Q to the 4/3 does. And so our picture is going to be exactly what we predict it to be, right? Short-run costs and long-run costs are equal when we're producing output, where K equals 16 is appropriate. But short-run costs are going to be greater than long-run costs when we're producing either more output than that or less output than that. So how about our marginal costs? Do we expect our marginal costs to be higher or lower in the short run or the long run? Or should it depend on how much we produce? The first thing I want you to think about to answer this question is that, again, right, when we have long-run capital equal to 16, so when we have Q equal to 8, and therefore K of Q equal to 16, we should expect that our marginal costs are going to be exactly the same. Right? In that case, if we think about the problem we're facing, we would say, in both cases, to produce 8 units of output, we would need 16 tractors and 16 workers. To produce a little bit more output, we can add an extra worker or add an extra tractor at the same cost, right? Enough workers, enough tractors to produce a tiny bit more output. And that extra worker that we'd add would be equally productive in the short run or the long run, right? So when we're thinking about marginal costs as well, when we're producing 8 units of output, when we have 16 tractors, our marginal cost should be exactly the same. Is that true? Well, if Q equals 8, right, our short run marginal cost is just 10 times 8. And our long run marginal cost is 40 times 8 to the 1/3, which is 40 times 2 is 80. Awesome. Exactly the same. How about if we had fewer than 8 units of output? So in that case, we'd still have 16 units of capital in the short run. In the long run, if we had fewer than 8 units of output, let's say that we were going to produce 2 units of output, we'd have fewer than 8 units of capital, right? We'd have 2 to the 4. Say we're going to produce 1 unit of output, we'd only have 1 tractor in the short run. We'd have 16 tractors in the long run. So should our marginal cost be greater or less in the short run? Well, in the short run, right, we've got all these tractors sitting around, nobody's using them, right? Or we're not using them very effectively. We've got way, way more tractors than we've got labor. So we'd expect that our marginal cost might be pretty low, right? Because we've got basically one input of production just sitting around for free, ready to use. In the long run, we need to increase tractors and labor. And this is exactly what we'll see, right? If we looked at, say, Q equal to 1, our short run marginal cost would equal what? 10 times 1 is 10. Our long run marginal cost would equal 40 times 1 equals 40, right? So when we're producing very little output, it's going to be cheaper, our marginal costs are going to be lower in the short run than the long run, because we've got all of this extra capital just sitting around, right, waiting to be used. It means that each additional worker is ultra productive in the short run. Whereas if we had some really, really huge quantity, let's say that we had Q equals 1,000, right? Our short run marginal cost would be 10 times 1,000 would equal 10,000. Our long run marginal cost would be 40 times 1,000 to the 1/3 is 40 times 10 equals 400. So we have a really huge output. Our marginal costs are going to be higher in the short run than the long run. And this makes sense too, right? If we want to increase our output past 8, in the short run we're adding more and more workers without adding any tractors, right? So the workers are getting less and less productive. We desperately want more tractors, but we're in the short run, so we can't add any more. In the long run, we're adding workers and tractors. So instead of worrying about diminishing returns to labor, we're worrying about diminishing economies of, right, we've got diminishing returns to scale, which is a much smaller effect, right? So because we're adding tractors and labor, we're getting less productive at a much, much slower rate. So what's this going to end up looking like? Well, if we graphed our two marginal costs, our short-run marginal cost, right, just a straight line up. Our long-run marginal cost is this 40q to the 1/3 thing, right? So it's going to have a shape that looks kind of like a square root function, right? Like this. And what we're going to say is, when we're producing less than the output, where we would choose 16 units of capital, right? Less than our ideal starting place output. Our short-run marginal costs are below our long-run marginal costs because of the fact, right, that our labor becomes more and more productive, as if we've got all these tractors sitting around unused. If we produce more than 8 units of output, our short-run marginal costs would be greater than our long-run marginal costs. Now, what does this mean for how much output we produce? It means, let's say that this is our price, right? So in this case, we would have chosen to produce 8 units of output in the long run. We would have chosen 16 units of capital. So this would be our short-run marginal cost curve. If the price fell, in the short run, we decrease our output to here, right? Along the short-run marginal cost curve. In the long run, we would decrease our output more because our long-run marginal cost is less steep than our short-run marginal cost, right? So a change in price is going to result in a bigger change in quantity. Same thing if our price is increased, right? If our prices increase in the short run, we'd add more workers to produce more output, but we wouldn't increase our output by as much because we can't increase the number of tractors. In the long run, we would buy more tractors as well, so our output would increase more in response to a price increase in the long run and in the short run. Awesome. Okay, so what's the big takeaway from this? Takeaway is our costs are always lower in the long run than the short run, unless we've got the exact right amount of capital in the short run, in which case they're equal. Which means our profits are always going to be larger in the long run than the short run. And our response to a change in prices has got to be larger in the long run than the short run, because our long run marginal cost curves are going to be above our short run marginal cost curves for a decrease in quantity, and below them for an increase in quantity. Okay, wonderful. Thank you so much for bearing with me. Looking forward to talking to you about this soon.